Welcome to my YouTube channel. In this video we are going to look at mass and weight, which is science paper 1 physics. So we are going to solve questions for 2020 and 2021. So let's get started. So the question for 2020, an object says an object of mass 75 kg on Earth is taken to the moon where the gravitational field strength is 1.6 newtons per kilogram. So we have this object which has a mass. So we can first write down the data. So we are saying we have the object with a mass which is equal to 75 kg, that is on Earth. And then we are saying we have been given the gravitational field strength, which is for the moon 1.6 newtons per kilogram. So this is in the question. So this is the mass of an object on Earth, and then this is the gravitational field strength on the moon. So let's look at the first question now. The first question says, what is the mass of the object on the moon? So remember, our question is saying what is the mass of the object on the moon, but in the question what we have been given is only the mass of an object on Earth. So the mass that we have here in the question is the mass of the object on Earth, but they want us to find the mass of the object on the moon. So here the solution is simple. The mass of this object on the moon will still be 75 kg. So even on the moon, the mass of the object will remain 75 kg. The reason is the mass of an object does not change. If you remember, mass is defined as the amount of particles that are in a substance. So a stone of mass 5 kg on Earth, even if you take it on the moon, it will still have the same number of particles, which is 5 kg. So in short, the mass of an object does not change. That's why even if we have been told that the object has a mass of 75 kg on Earth, even on the moon, the mass will still be the same, which is 75 kg. So this is the solution for part A. Then coming to part B, the question is saying calculate the weight of the object on the moon. So the weight of the object, so for weight, the formula is weight is equals to mass times gravity. Okay, so which is simply Wm multiplied by G. So our mass of the object on the moon, we have said it's 75 kg in A. Then we are multiplying by the gravity for the moon because they want the weight of the object on the moon. So we multiply by the gravitational field strength, or the force of gravity for the moon, which is Newton per kilogram. Then when we multiply 75 multiplied by 1.6, we'll get 120. And the SI unit for weight, as you may know, it is Newton. So the unit that is accepted worldwide when you're calculating weight in physics, it is the Newton. That is the symbol N. So that's the solution for part B. Then we have part C. So part C is talking about we give two differences between mass and the weight. So how we differentiate, we first begin with the definition. So we're going to say weight is the pull of gravity, on an object, so weight is the pull of gravity on an object, while mass is the amount of particles in a substance. So the first difference is that weight, we define it as the pull of gravity on an object, while mass is defined as the amount of particles or matter in a substance. So that's the first difference. Then the second difference will be mass of an object. Mass of an object is constant or does not change while the weight of an object changes. So if you have a stone of 5 kilograms on Earth, you take it on the moon, the number of particles in it will still remain 5 kilograms, but the weight would be different here on Earth and on the moon. The reason is that on Earth the gravitational force is 10 newtons per kilogram, while on the moon the gravitational field strength is 1.6 newtons per kilogram. So that is it. So because weight is influenced by gravity, it changes, it varies. On Earth the value is different on the moon, but with mass it is constant. So these are the two differences between mass and weight. So these were the solutions for the 2020. So let's check the other question for 2021. Okay, so